In the last session, actually, during our last session, what we discussed is about the planes, the different types of planes. Actually, the reference planes, the three reference planes. Then the different patterns of planes, the patterns of planes, how these three reference planes, the main three reference planes, that is the horizontal plane, the vertical plane, the profile plane, all these planes are made into two dimensions. That is the arrangement of these planes, not the planes. The planes itself is two-dimensional objects, but the arrangement of these three planes is in three dimensions. So how we can convert that particular arrangement of these three planes into two dimensions, that we have seen in the last class, especially in the first angle method, first angle projection method, how it is being converted, that we have seen. So let's again look into it once again. So this is the pictorial representation of the three planes, that is the vertical plane, the profile plane. Here it is a vertical plane, then here profile plane, and here it is the horizontal plane. Actually, we have seen a three-dimensional animation of, not animation, a representation of that one in one of the modeling softwares also. So then these three planes, then here is the XY line, and the observer looks in this direction. And in order to convert this one into two dimensions, what we do is we rotate the HP, the horizontal plane, 90 degree clockwise, 90 degree clockwise. And like this, it is rotated 90 degree clockwise. And then the profile plane, if we need the side view, then the profile plane is rotated 90 degree anti-clockwise in the opposite direction. Then 90 degree anti-clockwise. So it will create a two-dimensional arrangement of these three planes. So actually, if we represent these three things, these three planes in two dimensions, the space above this line represents the XY line. See, this line represents the XY line. So the portion above the XY line is XY line represents the vertical plane, and towards the right, actually we draw another line in order to separate the vertical plane as well as the profile plane. We draw another line like this also. So this is X1, Y1. This line is also drawn whenever we need a side view. If we want to draw the side view, then we draw a vertical line which is perpendicular to XY line, and we name it as X1, Y1. And this particular line differentiates between the vertical plane and the profile plane. So in this case, if we consider XY as well as X1, Y1, this portion represents this entire portion, that is the area that lies between X and X1, this area. This area represents the vertical plane, and this area represents the horizontal plane, and this area represents the profile plane. And this is this particular area. This area is nothing actually. Normally, there won't be any drawing in first angle projection method in that particular area. There will be some drawings if you want to draw the side view. In that case, there will be some lines will be there, but it is not part of our original drawing. So like it is known as the construction lines. So that will be there on the right hand side of bottom part. So these three parts is of importance to us, and out of which only these two parts is important, most important for us, these two areas. This one is important only when we need to draw a side view. In most of our drawings, we doesn't want to draw the side view, but in some cases, in some exceptional cases, we need the side view also. So these are the drawings, or I mean the two-dimensional representation of the three-dimensional arrangement of the planes. So I hope you understood how this will look like. So this is so obviously in first angle projection, we have already said that in first angle method, the object is placed in the first quadrant and the observer is looking away from the vertical plane, that is, the object will be in between the observer and the vertical plane. So the front view will be projected towards the vertical plane. Anyway, in any case, the vertical plane contains the front view. So the front view will be in this area, and the top view is always projected to the horizontal plane. So the top view will be here in this position, that is below the XY line, and the profile plane contains the side view. That is, in this case, it is left side view. If it is right side view, then it has to be towards the left of the vertical plane. So this is the orthographic projection method for first angle projection. Now, let's consider some of the orthographic projections of points, lines, planes, and solids. When we consider the orthographic projections of points, lines, planes, and solids, why we go in this way? Because all the solids are made up of planes. Different planes constitutes a solid, and each plane is made up of different lines, or each plane can be represented by different lines. So, and each line is represented by different points, various points. So that way we go in that direction. That is, first we go for the orthographic projection of points, then the orthographic projection of lines, then orthographic projection of planes. Actually, it is the projection of planes is not in your syllabus, so we will be doing only 1 or 2 problems related to that one. And then finally, the projection of solids. And as you may well be knowing, that is, you might be knowing that in order to draw a subject, to draw an object, that is, to draw the projections of any object, there at least 3 elements are required. The following information, that is, at least 3 information is a must. And these 3 information is, one is the object which we want to draw with its description. A well-defined description is required. Ambiguous description of the object will result in ambiguous drawings. So we will not be completed correctly or exactly if the description of the object is not well defined. So in our case, the objects can be points, lines, planes, or solids. So all these things, out of which only lines and solids are important for our course. Points and planes are in order to understand the things, understand how it looks like or how it is being drawn. So that is why we study points as well as planes. But lines and solids, it is necessary, it is compulsory in our syllabus, and you have to study how to draw, how to create projections of lines as well as solids. But in order to understand these projection of lines as well as projection of solids, projection of points and a projection of planes is also needed. So the object in our case will be point, line, plane, or solid. And how it can be defined, that we will come to it later. We will discuss it later, because even if I say it right now, you may not understand how it can be completely defined or well defined. So then the second one is the observer, the person who is observing this particular object, the object that is under consideration, that we have to observe. So that is the observer. So in this case, in our orthographic projections, the observer always observing perpendicular to the respective reference plane. The observer will always be observing perpendicular to the respective reference plane. That is, if it is the front view, the observer will be observing perpendicular to the vertical plane, and if it is the top view, the observer will be observing perpendicular to the horizontal plane, and if it is side view, he will be observing perpendicular to the profile plane. So that is the condition. Then the next thing is the location of the object. What is the location of the object, where it is placed, or the position, the exact position of that particular object. So the position of the object is given with respect to the HP as well as VP. With reference to the VP and HP, we have defined that there are 4 different quadrants. So the location of the object can be in any of the 4 quadrants. And the second condition is the distance between the HP and the object, distance between the VP and the object, and the angle, if it is a line or a plane or solid. In points, the angle is not of importance, but in lines, planes, solids, etc., the line, the angle a particular line or a plane makes with the reference plane, that is also important. So that defines the location. So these three things are important, that is object, observer, and location. And for the time being, for orthographic projections, we doesn't have to bother about the observer. We doesn't have to bother about the observer because the observer is always perpendicular, looking perpendicular to the respective reference plane. So the observer can be avoided in the case of orthographic projections. But the object as well as the location of the object is important. And whenever you are looking into a particular question or a particular problem, first you have to identify what is the object, and the second one is what is the location of the object. And depending on the location of the object, we have to draw the projections. Now, there are some terms. When we say that above and below, it is always with respect to HP, because HP is the horizontal plane. And if we say that the object is, say if it is a point, the point is above HP and it is below HP. It can either be above HP or it can be either below HP, or the third condition is it can be on HP also. That is, there are three different conditions for a point. It can be above HP, it can be on HP, or it can be below HP. So there are three different conditions. So always above and below is with respect to HP, and the terms in front and behind is with respect to VP. In front means in front of the plane, in front of the vertical plane, and behind the vertical plane. And there also the point can be in three different conditions. One is in front of the VP, and the second one is in VP, and the third one is behind the VP. So these are the four terms that you should be knowing, that is above, below, in front, and behind. And depending on these particular conditions, the object can be in the first quadrant, second quadrant, third quadrant, or fourth quadrant. And obviously the objects can be placed in any one of the four quadrants that is described by, or that is defined by these four terms. Above and in front means first quadrant. Above and behind means second quadrant. Below and behind means third quadrant. Below and in front means fourth quadrant. That is obvious, that you know. So that is obvious. And based on these four terms, the objects can be placed in any one of the four quadrants. And obviously it can be either in HP, or it can be either in VP, or it can be both in HP as well as VP. How these different conditions comes up, let's see. So when we are drawing the front view as well as top view, as I said, depending on the quadrant in which the particular object lies, the front view can be above the XY line or below the XY line, depending on, because we are always rotating the horizontal plane 90-degree clockwise. If it is in front of VP, if the point is in front of VP, the top view will always be below the XY line. But if the top view is behind VP, if the object is behind VP, the top view will always be above the XY line, since we are rotating it 90-degree clockwise. So whatever is behind, so it will be something like this. I hope you can see this. So it will be something like this. So in that case, if we rotate it, and the line joining these two hands, that is the XY line, and if we rotate it 90-degree clockwise, it will be like this. Oh, okay, sorry, the 90-degree, the clockwise direction is from my point of view, and so if we rotate it like this, this portion is behind the XY line or behind the VP, so that comes above the XY line, and this portion was this portion is in front of the VP. So that comes below the XY line. If I look from my point of view, and if we look from your point of view, this portion is, see, this portion is in front of the VP, and this portion is behind the VP. If I rotate it 90-degree clockwise, see, like this. So the whatever is in front of the VP comes below the XY line. Whatever is behind the VP comes above the XY line in top view. So, and it is the same as we consider, if we consider the front view also. If the line, if the point, or if the object is above the XY line, I mean above the horizontal plane. So this is the horizontal plane, and this hand is above the horizontal plane, and this is below the horizontal plane. And if we look from the front, from your side, we are looking from your side. So whatever is above the HP will be above the XY line also in our drawing, above the XY line, but in front view. But whatever is below the XY line, whatever is below the XY line, that will be below the XY line. Oh, sorry, whatever is below the HP, that will be below the XY line. So that way, depending on in which quadrant the object lies, the top view and the front view can be above the XY line or below the XY line. So how to differentiate these two things when we draw something? So in order to differentiate these things, actually there we have to follow some naming conventions. The naming conventions are nothing but how an object should be named in front view as well as top view and side view. That is it. So like if we consider a point A, its top view will be named always as A itself, small letter A. Point we always represent by capital letter A, and the top view will always be represented by small letter A. That you should remember. In order to represent the drawing or the projections, we always use the small letters. So small letter A represents the top view. And if it is a line is normally denoted by the two endpoints, line AB. So in that case, the line will be represented by small letter AB, the top view. The top view will be represented by small letter AB. Its front view, if it is a point, the front view of the point A will be represented as A dash, and the front view of the line AB will be represented as A dash B dash. So if you see A dash and B dash, or if you see A dash only, then you can obviously determine that that particular point is the front view of the point A, the point capital A, and its front view will be represented by A dash. So if you see A dash in a particular drawing, you can determine that it is the front view of that particular point. And in line, if it is a line, if you see AB, small letter AB, you can determine that it is the top view of that particular line. And the side view is always represented with the two dashes. So two different dashes will be there. So A double dash, we call it as A double dash. So it is the side view. And A double dash, B double dash will be the side view of line AB. So this is the naming conventions. This you should remember. That is, the top view of a point is denoted by its small letter. If the point is capital A, then its top view is small a. If the point is capital P, its top view will be small p. And the front view will be represented with a dash. So A dash will be the front view of the point A. If the point is point P, then its front view will be P dash. And the side view will be denoted with the two different dashes, that is double dash. So A double dash represents the side view of the point A, and P double dash represents the side view of the point P. Likewise it goes. So the same system of notations should be followed in case we use the numbers. But in case of numbers, there won't be. If the point is 0.1, we doesn't have a small 1. So we always use it as 1 and 1 dash itself. In the case of top view and front view, its side view will be 1 double dash. So the point can be named using alphabets or it can be numerals. In alphabets, in order to represent the top view, front view and side view, we use A, small letters A dash and A double dash respectively. And if it is numbers, we use it with the same number, then the number dash, then number double dash. If it is the point 1, then 1 is the top view, front view will be 1 dash, and the side view will be 1 double dash. So this is the naming conventions. So now you have to remember that is the front view. The front view is always obtained in the vertical plane. The top view is always obtained in the horizontal plane, and the side view is always obtained in the profile plane. And in order to convert the three-dimensional arrangement of the planes to 2 dimensions, the horizontal plane is always rotated 90-degree clockwise. The vertical plane remains as it is, and the profile plane is rotated 90-degree anti-clockwise. So that is the things that you should remember. And now methods of drawing orthographic projections. The methods, actually, there are 2 different methods. One of them we have already described. The first angle method, the first angle projection method, that we have already discussed. That is, the views are always drawn by placing the object in the first quadrant. The object will be in the first quadrant. So the front view will be above the XY and top view will be below the XY. The front view will be always above the XY and the top view will be always below the XY. That is the first angle projection. And the left side view will be, if we draw the left side view, it will be towards the right of the front view. And if we draw the right side view, it will be towards the left of the front view. So that is the first angle method. And the second method is third angle projection method. Why third angle projection method? When the object is placed in the third quadrant, it is the third angle projection method. In third angle projection method, the top view will be above the XY. Since the horizontal plane is rotated 90-degree clockwise, as you see from your side, if I rotate the horizontal plane, this is the horizontal plane, and if I rotate it 90-degree clockwise, when you see from your side, so this is the portion that is the portion of the horizontal plane that is behind the VP. That comes above the XY line. So that is why the top view becomes above the XY. In third angle projection, the top view will be above the XY line, and the front view will be below the XY line. This is the vertical plane, and this portion is below the horizontal plane, and the front view is obtained here, so it remains below the XY line. So that is the only difference. That is, in first angle projection, the front view is above the XY and the top view is below the XY. And in third angle projection, it is the opposite. The top view is above the XY and the front view is below the XY. And in our drawings, unless and until stated otherwise, we always go for the first angle projection method. We doesn't go for the third angle projection method. And in the case of playing lines and points, in the case of lines as well as points, we doesn't have to bother about first angle projection or third angle projection, since the actual position of the object will be given. This type of projection methods are applicable only when we draw some solids or planes. If we draw the solid or the plane, then you have to follow either first angle projection or third angle projection. But when we are drawing a particular point, the position of the point will be given with respect to the HP and VP. And depending on that one, we can find out whether it is lying in the first quadrant, second quadrant, third quadrant, or fourth quadrant. And then we can draw it accordingly without considering about whether it is, without bothering about whether it is first angle projection or third angle projection. But this first angle projection and the third angle projection is applicable only when we are drawing the solids. Okay, then why we are not going for the second angle projection as well as the third angle projection? In the second angle projection, the problem is that the object, we are placing the object in the second quadrant. So the second quadrant is behind VP and above HP. Above HP means the front view will be above the XY line. Above HP means the front view will be above the XY line. And behind VP means the top view will be above the XY line. That means both the views will be above the XY line. If we draw or if we consider the second angle projection, that is placing the object in the second quadrant, if we draw the projections, then the front view as well as the top view will be above the XY line. Obviously, the drawings will be overlapping. Both the views will be overlapping. That is really an inconvenience. So that is why the second angle projection is not being used. And considering the fourth angle projection, if we place the object in the fourth quadrant, it is in front of VP and below XY line. Below HP. Below HP. Below HP means the front view is below XY. Below HP. Below HP means the front view is below XY line. And in front of VP means the top view is below XY line. In front of VP. We obtain the top view in the horizontal plane, and when we rotate it 90 degree, the horizontal plane, when we rotate it in the 90 degree clockwise, it comes like this. From this side, if I look, it comes like this. So it will be below XY line. So the front view as well as the top view will be below the XY line. So again, the same case with the same case as with the case of as in the case of the second angle projection itself. So both the drawings will be, both the views will be overlapping. So that is why we doesn't follow the second angle projection as well as the fourth angle projection. We always follow the first angle projection or the third angle projection. But in India, we normally follow only first angle projection method unless and until it is stated that you have to follow the third angle projection method. And again, this third angle projection method or first angle projection method is to be considered only when you are drawing a specific object, or like in solids or planes. Otherwise it is always in the case of points as well as lines. We doesn't have to bother about whether it is first angle projection or the third angle projection. So now the symbolic representation of these things is like a frustum of a cone standing on HP on its base. That is the condition. So this is the frustum of a cone that is standing on the base. So in the case of a frustum standing in on HP on its base, the front view will be something like this, only a trapezium. So in the top view there will be two circles. This is the top view and this is the front view. So in top view there will be two circles, one representing the bottom circle, bottom circular face, and the other one representing the top circular face. So these are the two views, the front view as well as the top view in first angle projection. In third angle projection, it will be reversed. The front view will be below the XY line. So in this case, in the third angle projection, we have to consider a ground line also. So in this ground line, the object rests. The object is resting on the ground line. So here it is the front view, the same as this one itself. And here this is the top view. So here also there will be two circles, but there is a slight mistake in this drawing, because this circle will be invisible, because since we are looking from this side, this portion will be visible to us, but this portion will not be visible to us. It will be hidden from our view. So these lines are drawn. This inner circle is drawn with a dotted line. The inner circle is drawn with a dotted line in the case of the third angle projection. This is the representation, the symbolic representation of the drawing. This is, we are not following this one, because we will be always following this first angle projection unless and until specified otherwise. So this is about the term. The term HP is used in first angle method, and for the same, the ground term is used in third angle method. So that's it. Now, first angle projection, we once again visit the first angle projection. In this method, in the first angle projection method, the object is assumed to be situated in the first quadrant. That is, the first quadrant means above the HP and in front of the VP. Above the HP and in front of the VP. So the object is in between the observer and the plane. The object is always in between the observer and the plane. So that is the condition. So the front view will be here above the XY line, and the top view will be below the XY line, and the left side view will be towards the right of the X1, Y1 line. So the X1, Y1 line is not represented here. So the profile plane will be towards the right of the X1 line, X1, Y1 plane. So this is the actual pattern of planes and views in first angle method of projections. Let's see the three-dimensional representation. Let this be the object, a rectangular block. That is our object. And in order to get the front view, we look from this side, from this angle. We look from this side. That is, this is the front, this is our front, and this is our top, and this is our side. So this is the condition. So if we look from this front side for front view, the VP will be there. The object is projected onto the VP to get the front view. And now for top view, you have to look from the top, looking down. You are looking down to the object, to the top face. And the top view is projected onto the horizontal plane. The horizontal plane will be below the object. So the horizontal plane is below the object. Now, in order to get the side view, you have to look from the side. Since we are going for the left side view, we are looking from the left side. If you want to get the right side view, you have to look from the opposite side. So we are going for the left side view. So this is the side from which we are looking. Now the profile plane will be on towards the right of the object. In the case of first angle projection, this is the condition of the first angle projection. The object is in front of VP, in front of VP. This is our VP, so it is in front of VP. This is HP, so this is above the HP. And obviously the profile plane, depending on the left side view or right side view, it can be the position of the profile plane can be different. So in this case, we are going for the left side view, so it is towards the right. The profile plane is towards the right. Now, in order to get the front view, what we do is we draw, or actually we emit, or we make 4 rays of light to travel perpendicular to this plane, perpendicular to the VP, and from the corners of the object, from the 4 different corners of the object. Because in order to represent this particular plane, we need only the 4 corners. If we have all the 4 corners, we can join them and we can find out. So the 4 corners of the object emits light which is perpendicular to the vertical plane. Or if we make a parallel source of light or parallel rays of light to fall on this object from the front view side, from the observer, from the side of the observer, the shadow will be generated like this in the vertical plane. So this is the front view. And in the case of top view, the top view, the light source will be above the object, and the source of light is parallel rays of light. It emits parallel rays of light. So the shadow of the object will be falling on HP will be like this. And the shape of this particular front view, will be same as the size of this this face of this blue face of the object. This is the front face, that is the blue face is the front face. So the front view will be same as the blue face of the object. And the top view will be same as the top face, that is in this case the green face of the object. It will be same as the green face of the object in size as well as shape. And in the side view will be like this. The side view will be same as the size and shape of the side view will be same as the side face of this particular object. So this is how the front view, top view, and the side view is obtained. And as you know, since the horizontal plane is rotated 90° clockwise, it comes below the below the XY line, like in this figure, the top view comes below the XY line. And since the profile plane is rotated 90° anti-clockwise, that is like this. This is rotated, the HP is rotated like this, that is 90° clockwise. And this is rotated, the profile plane is rotated 90° anti-clockwise. In the case of left side view, in the case of the right profile plane, it is rotated 90° anti-clockwise. If it is the right side view, in that case, the left profile plane will be rotated 90° clockwise itself. So that is, it should not coincide with the vertical plane. When we are rotating the profile plane, it should not coincide with the vertical plane. That is the condition. So it is rotated 90° anti-clockwise. So the views, the front view will be here, and the top view will be here, and the left side view will be here. And this is the first angle projection method. And now we move on to the third angle projection method. As you know, in third angle projection method, the object is placed in the third quadrant. That is, the third quadrant means below the HP and behind the VP. Below the HP and behind the VP. Since it is below the HP, the front view will be below the XY line. And since it is behind VP, the top view will be above the XY line. The top view will be above the XY line. And the left side view will be towards the left of the front view itself. So here will be the X1, Y1 line will be here. So in the case of third angle projection, the left side view will be towards the left of the front view itself. And the side view is always drawn towards the left or right of the front view, not to the top view, to the front view. So the left side view will be towards the left of the front view. Now for this one also, we have a small animation. This is the ground and the object is placed here. And for front view, we are looking from this position, from the right of the object. And the top view, we are looking from the top. And for side view, we are looking from the left side. And now in this case, this is the third angle projection, and so the HP, the horizontal plane will be lying above the object. The horizontal plane will be in between the observer and the object. So this is the horizontal plane, and the rays of light is projected towards the HP, and the top view is obtained here. And the VP will be again. The VP will be in between the observer and the object. So the rays of light starting from the corners of the object that fall on the VP, and the front view is generated. And in this case also, the top view will be, the shape of the top view will be same as the shape of the top face. and the shape of the front view will be same as the shape of the front face, and the picture plane, the profile plane. The profile plane will be lying in between the object and the observer when he is observing from the side. So in this case, the side view will be obtained here. And when such an arrangement is coming up, if we rotate the HP, the horizontal plane 90° clockwise, it will go above the XY line. So if we rotate this one 90° clockwise, it will be like this. It will come above this one, this VP. And if we rotate this one again 90° anti-clockwise, so that should be like this. Then it will be coming here, like this position. So this is the difference between the first angle projection and the third angle projection. And you don't have to bother much about the difference between the first angle projection as well as third angle projection, because there won't be any question like that when whether if a particular point is or a particular object is lying in the first quadrant, where the front view will come or where the top view will come. The only thing that you have to remember is there are two different types of projection. One is the first angle projection and the second one is third angle projection. And why second angle projection and fourth angle projection is not being used, and what are the arrangement of the drawings, arrangement of the projections, the front view, top view and side view in this case. So these are the conditions. Now let's start with our original journey. The original journey is we want to study the orthographic projections. Until this, we were describing all the basics that you should know, you should understand before going for the actual projections, before dirtying your hand with your pencil and eraser. So now the orientation of the point in space. In space, the space is divided into 4 quadrants depending on our condition. Based on the 2 HP and VP, we have divided the the space into 4 different quadrants, and the point can be in any of the 4 different quadrants. So depending on the position of the point, there are a total of 9 different possibilities are there. So we start with each one of the possibilities and how the projections will look like. So the first condition, the first orientation that is possible for a point is, the point is lying in first quadrant. That is, it is above HP and in front of VP. And the second condition, the object is, the point is lying in the second quadrant, that is above HP and behind VP. Third, the point is in third quadrant, below HP and behind VP. Fourth quadrant, below HP and in front of VP. These are the 4 orientations of points depending on the quadrants in which it lies. Now there are 5 more conditions. The first one is in plane, that is above HP and in VP. The point is above the HP, but it is in VP. It is neither in front of VP nor behind the VP. So it is in VP. So that is the 5th condition. Then the 6th condition is again it is in plane. In this condition, it is below the HP and again it is in VP itself. And there is another in plane condition. It is now in HP and in front of VP. That is, the point is lying in HP and it is in front of the VP. And the 8th condition, that is again in plane condition, that is it is in HP and behind the VP. These are the 8 different conditions. Then there is a 9th condition, that is again an in plane condition, but at this time, that is in the 9th condition, it is both in HP and both in VP. So this condition is when the point lies in in the XY itself, or the line of intersection of HP and VP. The line of intersection of HP and VP is known as the XY line. So when the point is lying in that particular line, that is the ninth condition. That is both in HP and in VP. So now let's look one by one in this condition, that is orientation of the space, point in space. So let's look the first condition, that is in quadrant 1, that is above the HP and in front of the VP. There is there are some missing. Let's look. Okay. In first quadrant, if we look into first quadrant, the point A1, we consider the point to be A1. It is above HP and it is in front of VP. The point is above the HP and in front of VP. So in this slide, I show it in three-dimensional as well as two-dimensional representations. And for this time, you just listen to all these conditions, and at the end of after describing all these 9 conditions, we will start doing our exercises. So in 3D, here is the HP, here is the VP, and here is the XY line. So what we do is in 2D, we again draw the XY line. So we draw the XY line. Here is this line, this violet line. This is the XY line, and in order to represent it in 2D, we draw a line, a horizontal line here. So it is the XY line. It is XY, and here also it is XY. We name it as XY. Now we consider a point which is above HP and in front of VP. That is in the first quadrant itself. This is the point A1. A1 is the point. Now what we do is we observe it to get the front view. In order to get the front view, we observe it from the front. So the observer, the red arrow and the red O represents the observer, and the red arrow represents the direction in which the observer looks, or the point is projected, the direction in which the point is projected. So this is the line. This is the line of projection. So A1 is projected to VP, and this is the point. This is the front view of A1. And we name it as A1 dash. Since the point is A1, the front view should be named with a dash. So it is A1, the point is a capital A1. So we name it as A1 dash. The A1 dash, in A1 dash, the A should be small letter. So A1 dash is the front view. Now the observer comes and looks from the top. Now the observer looks from the top. Again, the red arrow indicates the direction of the projection. So A1 is projected downward to HP. So here it is the top view. Now this is the top view, and it is represented by A1, small letter A1. So this is in 3D. This is the concept. This is the concept how it is being done. And A1 is the top view. So now we have to convert these things into 2D. But in 2D, till now what we have is only XY line, and how to get A1 dash and A1 in this 2D. That is the condition. Now what we do is we assume a line which is perpendicular to the XY line and passing through A1 dash in our 3D. So this blue line, this new blue line which appears. So this up line represents this line is perpendicular to the XY line and is passing through A1 dash. And we draw a corresponding line in the 2D also, a line which is perpendicular to XY. Since we doesn't know where is the position of A1 or A1 dash, so we just arbitrarily take a specific position to draw the perpendicular line to XY line. So this blue line is drawn here. This blue line is drawn here. So this particular line is known as the projector line or projection line. This line is known as the projector line. The projector line is nothing but the line on which the projections of the point lies. The projector line is the line on which the projections of the point lies. So now we know that A1 dash should be somewhere in this line, and the distance of xy and A1 dash, the distance of xy and A1 dash should be the distance equal to the distance between A1 and HP. It should be the distance between capital A1, A1 in 3 dimension, that is this point, and the HP. So that should be equal to the length of this line, or the length of this line. Since HP is perpendicular to VP, and this line is also perpendicular to VP, this distance, the distance of A1 from HP should be equal to the length of this particular blue line. So we can measure the distance of that particular line here, and we can mark the point A1 dash in the front view. So this is the point A1 dash, which is the front view of the object, of the point. Now, in order to get the top view, what we do is we draw a line which is perpendicular to XY and passing through A1 in top view. So this is that particular line. So if you observe this line as well as this line, the two lines which we draw as perpendicular to XY line, both meets at this position. So both meet here. So we reproduce this particular drawing, this particular line in our two-dimensional drawing, in our 2D. Since both the lines coincided in this position, it should coincide in two-dimensional drawing also at XY. So this projector line will be a continuous line. It will be a continuous line which is crossing XY line. And now you can mark the point A1 on this projector line, and it should be below the XY line, since it is this distance. This HP is rotated 90 degrees like this clockwise, so it should come below the XY line, and the distance of A1 from XY line should be equal to the distance of this particular blue line. That distance is equal to the distance of A1 from VP. The distance of A1 from VP is the distance of this line. So that length can be marked here, and we can obtain the top view. So this is the condition. Now from this one we can conclude that in 3D, if the point is above the HP, if the point, like in A1, the point is above the HP, the front view is above the XY line, and if the point is in front of VP, the top view is below the XY line. So this can be concluded. And the other conclusion which is not written here is the distance between A1 dash and the XY line. The distance between A1 dash, or the front view, and the XY line should be equal to the distance of the point from HP. The distance of the point from HP, and the distance of the top view from XY line, the perpendicular distance of the top view from XY line, that is the distance of A1 from XY line, should be equal to the distance of the point A1 from VP, that is the distance between VP and A1. So that should be equal to this particular distance. So likewise, it is very easy to draw the front view as well as top view if we know the distance of the point from HP and VP. What we have to draw is, what you have to do is, you have to draw a horizontal line and name it as XY line, and then draw a perpendicular line which is known as the projector line. And on projector line, you have to mark the distances above XY line if the point is above the HP, and the distance, how much distance the point is above HP, that distance you have to mark above the XY line, and hence you can get A1 dash. and how much distance the particular point is in front of VP. That distance you can mark below the XY line on the projector line itself. Then you can get the point A1, that is the top view. So this is the condition.